All right, hello and welcome. Today we're going to jump right into the world of machine learning. And look, I know it can sound super complicated, but I promise you we're going to break it all down in a way that's actually fun and makes a ton of sense. So let's get into it.
So, have you ever tried to read an article or watch something about AI and you just get totally lost in all the jargon and the crazy math? Yeah, you are not alone. It feels like so many explanations out there are just, well, they're kind of dry and maybe a little too technical?
But this right here, this is going to be different. We are promising, as you can see on the screen, no more confusing bazinga words. Our goal today is just simple. Make machine learning make sense. That's it.
Okay, so let's tackle the big question right away. What is machine learning? When you boil it all down, it's really about teaching a computer to learn by doing. It's almost exactly like a robot that just learns from practice.
I love this analogy. It just makes everything click. Imagine you've got a robot, and its job is to sort your laundry. Now, when you first turn it on, it has no clue what it's doing. So you have to show it. Okay, this is a sock, this is a t-shirt, this goes in the whites pile. After watching you do it a bunch of times, it starts to see the patterns. And pretty soon, it can sort clothes it's never seen before all by itself. That right there is the core idea of machine learning.
And that little story perfectly sets up the more formal definition. Machine learning is simply a way for computers to figure out how to do something without a person having to write code for every single possible step. Instead, they just get better and better over time, the more data they see and the more they practice. Now, to really see how this works in the real world, let's follow a story. Let's meet you. She's a gardener, and she wants to use machine learning to predict how many tomatoes she's going to get from her garden. Her journey is going to make all these abstract ideas super clear. So the first tool you grabs from her new toolbox is something called linear regression. And honestly, just think of it like connecting the dots. She keeps track of how many hours she waters her plants, and then she counts how many tomatoes she harvests. Linear regression is all about trying to draw one single, straight line through all that data to show the relationship. More water, more tomatoes. Seems simple enough, right? But here's where you hits her first little snag. You can draw a lot of different lines through all those data points, can't you? Some lines might be really steep, others could be almost flat. So the big question becomes, how in the world does she find that one single perfect line that's going to give her the best predictions?
Well, to solve this puzzle, you get a little help from a powerful guide. And its name is gradient descent. This is the secret sauce for finding that perfect line we were talking about.
Okay, so think of gradient descent like a game. It's like you're trying to guess the combination to a lock. Step 1, you just make a random guess. Draw any old line. Step 2, the algorithm tells you how good your guess was. It gives you feedback like, you're a little too high, or nope, a bit too low. Step 3, based on that feedback, you make a tiny little adjustment to your line. And step 4, you just do it again, and again, and again, making these small improvements each time until boom, you've landed on the best possible line.
So Yui finds her line. She's feeling great. But of course, a new challenge pops up. Let's call it the Tower of Blocks problem. And it's all about this tricky balancing act between making your model too simple and making it way, way too complex.
So on one side, you've got something called underfitting. This is like trying to build a tower with only a few blocks. It's short, it's wobbly, it doesn't really tell you much, and its predictions are going to be pretty bad. But on the other side, you've got overfitting. This is like building a tower that's way too tall and spindly. The model is so complex that it hasn't just learned the patterns, it's basically memorized every little random detail or noise in the data. So yeah, it works perfectly on the old data it's already seen, but the second you show it something new, the whole tower just comes crashing down. So the question for you is, how does she build that perfect tower? The one that's just right? Well, she's going to need a few more tools to help her find that sweet spot right in between underfitting and overfitting. Her first new tool is cross-validation, and you can think of this like a little guessing game. The whole idea is you don't just test your model one time. You actually split up your data into different chunks and you test it again and again on each chunk. This helps you figure out if your model is actually a good, consistent guesser or if it maybe just got lucky that one time.
All right, next up is regularization. The best way to think about this is like adding some rules to the game. It basically introduces a penalty anytime the model tries to get too complex. So by discouraging that complexity, it helps stop the model from cheating and just memorizing all the data instead of actually learning the important patterns.
And the third tool is feature selection. This one's fun. It's like telling a kid they can only play with their absolute favorite toys. Instead of overwhelming the model with every single piece of data you help it pick out only the most important, most relevant information. This helps the model focus on what really matters to solve the problem. So now, with these new tools in her belt, you can build a really strong, reliable model for her tomato predictions. But as she's about to find out, her journey into machine learning is really just getting started. She then stumbles onto this other really cool idea, feature engineering. This is basically the art of creating new, even better information from the data you already have. It's kind of like taking a basic cake recipe, but then making it way, way better by adding stuff like chocolate chips or vanilla. You're not changing the basic ingredients, you're just combining them in smarter ways to get a much tastier result, or in our case, a much more accurate prediction. This is where a lot of the real magic happens. And she learns that beyond that first tool, linear regression, there is a massive toolbox filled with other powerful methods. You've got things like decision trees, which are like flowcharts that ask a bunch of yes or no questions to make a prediction. Then you have random forests, which are literally hundreds of those decision trees all working together to make an even better prediction. And of course, there are things like artificial neural networks, these super complex systems that are modeled after the human brain, and they're the engine behind stuff like self-driving cars. Every one of these is a different tool for a different kind of job. And in the end, what this whole journey really shows us is that learning about machine learning isn't just about memorizing some formulas. It's an adventure. The source material puts it so perfectly, saying it's like a novel, full of adventure, challenges, and discoveries. So I guess the real question to leave you with is, what problem are you going to try to solve on your adventure?